Sanchez is the director of the Biological Technologies Office at DARPA, and he also works with decoding brain activity, helping patients with memory deficit, and essentially interfaces to the body and the brain. So please, Justin, come and talk about that.
All right. Thank you so much for having me. It's a pleasure to be here. Techonomy is one of my favorite meetings, and so many great bits of conversation before. So again, I'm Justin Sanchez. I'm the director of the Biological Technologies Office at DARPA, and we've been working on neurotechnology, or the connection between brains and machines, for nearly a decade now. And one of the things that I hope to achieve today is to share with you what the ground truths are. Okay, there's a lot of hype and there's a lot of speculation about this convergence between brain and machine, but I'm going to show you today what is truly possible by some of the pioneering work that we've been doing at DARPA. So during this time at DARPA, we have developed platform technologies to the brain of the nervous system, direct interfaces to the nervous system. And in the center of the screen, you'll see an example of one of these interfaces. This is a 4 by 4 millimeter array of sensors. There's about 96 sensors, and they are placed directly on the brain or directly in the peripheral nervous system. And through a sensor of this type, there's virtually no part of the brain or peripheral nervous system that we have not studied up till today. And we can record and write in signals in real time, so bidirectional communication between a computer and the nervous system with one of these kinds of interfaces. Now, the interface itself is a huge achievement, but what can you do with this kind of neural interface? What can a person do with this kind of neural interface? And I'd like to share a story with you. Okay, and the story I'd like to share with you is one. There's a person. His name is Nathan. He's one of the first people to pioneer one of these neurotechnologies with us. And a little bit about Nathan. So he's paralyzed from the neck down. He was injured in an automobile accident, and he volunteered to be a part of our studies. And Nathan had 2 sensor arrays, one placed on his motor cortex and one placed in his sensory cortex. And you can actually see coming out of the top of his head, that's where the signals from his brain emanate from. And they travel through a bunch of cabling back to that bank of computers that's in the center of the screen. And then those brain signals are decoded in real time and are sent to that robotic arm, which DARPA also developed. And Nathan had the wonderful experience of meeting a president of the United States and actually being able to shake hands with the president of the United States just by thinking about it. You can imagine, for a person like Nathan, who's paralyzed and stuck in his wheelchair, that this new communication channel, right, between his brain and a machine can transform his life. And so much so that he got to have this experience with the president of the United States. So while a lot of people are speculating about neurotechnology, whether it's real or not real or what one could do with it, this is a very real example of actually being able to actuate something with your mind and communicate with the president. Now, what's even more remarkable about this demonstration here is that Nathan had a second function associated with this neural interface. So we actually put force sensors on the fingertips of the robotic arm, and as the president placed his hand and the robotic arm together, signals went back from those sensors through that bank of computers again and directly back into Nathan's sensory cortex, and he could feel the president's hand like he was really shaking his hand. And I'd like to share with you a little video next of Nathan and what he can actually do in terms of the resolution and the precision of this neural interface. Okay, so Nathan, in this video that I'm about to play for you, he's blindfolded, okay? Can't see what's happening. Again, still using that same robotic arm and that same brain interface. And the researcher that's in this video here is going to press upon the fingertips, and Nathan has to tell the researcher which fingertip he thinks that he's actually pressing on. So here it is.
Index, pinky, middle, index and middle.
From this moment, we knew that the relationship between humans and machines was forever changed. Okay? This was a first example of using a robotic system with a direct brain interface to actually feel what was happening in the world. And a part of that video, I don't know if you caught it right at the end, Nathan kind of smiled. Right when we started this experiment, we said we're just going to be pressing individual fingers, and the experimental pressed 2 fingers. And he kind of said, oh, you tried to trick me, but I knew exactly what you were doing. So it was a really kind of special moment for us and for Nathan. Now, another aspect about Nathan that is really interesting is he's a gamer. So we asked Nathan, what do you want to do with your neural interface? And he says, well, I want to fly an aircraft. And we said, okay, we can let you fly an aircraft. And then he kind of comes back and says, well, what if you can also allow me to fly additional aircraft? So we said, well, we can also try that out. So in this video that I'm about to show you, again, he has a direct brain interfaces controlling this primary aircraft, which is in the center of the screen. But we also gave him 2 transformers, okay? And we said, okay, Nathan, while controlling that first aircraft, you also have to control the spacing of the transformers. So the question that we're really exploring here is, how many things can you control with your mind? What is the extent of actually being able to do that? And Nathan was one of the first pioneers of showing that you can control multiple vehicles just by thinking about it. All right, so he's navigating that primary aircraft. You can see the additional aircraft that are at the top. In a brief moment here, we're going to give him a cue that we want him to change the position of those aircraft that are at the top. There's the cue. And now he's controlling all 3 aircraft at the same time just by thinking about it. Again, this opens up a lot of questions, right? Again, he's controlling 3. Well, what about 4 or 5? What is the limit on which a brain and a machine can work together in order to do a task together? All right? Really opens up the possibilities for the future. Now, everything that I've shown you thus far with Nathan is that direct interface using that 4x4 millimeter of arrays on his brain. But there is a new kind of technology that is starting to emerge. And this is emerging from the convergence between synthetic biology and neuroscience. In this particular example, we have used gene modification kinds of techniques in order to create neurons in the brain of a living organism that fluoresce when they become active. So the future may hold a new technology, a new way of interacting with the brain via light. Perhaps we can illuminate the function of the brain just directly through light. And while these technologies are not yet ready for humans, they are showing the possibilities of what may occur in the future, a direct brain interface just using optical kinds of techniques. Now, you may be thinking, these kinds of neurotechnologies and brain-machine interfaces are really interesting, and they are, but they are extremely powerful kinds of technologies. And with all powerful technologies, we need to think very deeply about what they mean for us and what they mean for society and what are the ethical, legal, and social implications. And in the future, will we view neurotechnologies as commonplace as getting braces or laser eye surgery? Or will there be a big gap between those who have access to neurotechnology and those who don't? I don't know. These are all questions that all of us in this room will have to answer. But I see a great future for neurotechnology, and I think that the choices that we make about neurotechnology will define who we are today and will absolutely define who we could become in the future. Thank you so much.
Really, really interesting, Justin. And I hope you got a chance to listen to most or all of
did.
the previews. Okay. So, before we get to that, obviously DARPA is part of the Defense Department, and this work partly started because so many people were getting injured in Iraq and Afghanistan, right? So just quickly talk about the genesis of it.
Yeah, so that was the absolute reason we got into doing this kind of research and development. And during my time at DARPA, I've been able to meet a lot of the service members who have sacrificed limbs or their lives in order to protect our freedom. And when you meet these individuals and you hear how special they are and how special their stories are, we said, look, we cannot give them technologies that are going to be substandard. We said we want to make them more whole again. We want to make them as good as when they were before they lost a limb. So that's why we started off building robotic arms and brain interfaces. We said we want to have near natural kind of control of those systems. And we've delivered upon that promise. And you can actually go and buy these robotic arms today commercially. And they provide new options.
But emerged from your work.
Absolutely emerged from our work. But so at the same time, though, while we were restoring these injured individuals, we said, well, let's explore the possibilities of neurotechnology and where it could go in the future. And that's really consistent with the mission of the agency. So the agency is also known for building the internet, right, or GPS. All of these technologies had their start in kind of DoD applications or realms, but they found a home in a future well beyond what we started.
Also, since it is the Defense Department, is there an offensive military implication of any of this?
So we're not doing any of that kind of work. But one of our missions and our goal is to think about technology anywhere in the world. And I think you brought up the question to the panel was, we can't be the only ones that are working on this. And the same holds true, again, even in this space. There are any number of people around the world that could be working on neurotechnologies. And we got to understand those technologies, and we need to make sure that we can stay ahead of those technologies. So we're absolutely going to explore it for defensive kinds of purposes.
Okay, I think we're going to have time for one or two audience questions if anybody wants to ask one. But before we do, especially thinking about the kind of work that Mary Lou's doing with infrared light and reading the brain, is that something you guys are interested in experimenting with also?
So we have the first generation kind of neural interface that I showed you here today, but we're always thinking about the future. And so I ended the talk on, well, what does neurotechnology mean for all of us? And without a doubt, we're not all signing up to get brain surgeries today. And again, if we're all going to be able to access this, we have to have a non-invasive or a minimally invasive kind of neurotechnology. And the biophysics of that is extremely hard. The science and technology needed to do that is extremely hard. And I haven't seen any technology that has really solved it yet. So we're still pursuing those kinds of techniques and are thinking about what is it actually going to be in the future.
How do you feel about Mary Lou's optimism that we are, say in 5 to 7 years, to be maybe a little further out than even she said, we could be in a place where we really are facing some of this potentiality?
So I'm always also an optimist when it comes to technology and the speed of technology. Here's a funny story with neurotechnology. I was at the first meeting of when DARPA started doing this kind of work. I remember a scientist stood up and said, it would be 50 years before a human would have this kind of technology, and we've done it in less than 10. Right? So when it comes to what is the potential of non-invasive neural interfaces for a lot of us being able to use, I think that's a very real possibility, and I think is right over the horizon.
Okay, wow. Okay. Who has a question or a comment? Okay, back there, and then we'll go here. Let's just get two voices on the floor, and then we have a couple minutes left for Justin to respond.
Hi, thanks for this. I'm David Berkowitz at Sysomos, and I was wondering, you showed the picture of our previous president. Do the different administrations change the priorities for DARPA at all? And is there anything that the current administration expressed interest in from you?
Yeah. So DARPA's mission is very much baked into the nature and the culture of the agency. Again, we have singular mission, breakthrough technologies for national security. So no matter what administration is in office, we're more looking at what are the global opportunities, what are the global threats, and trying to stay ahead of those. Again, thinking over the horizon and trying to figure out what those solutions to those problems are. So again, administrations come and go. A lot of things change, but when it comes to science and technology, we're thinking over the horizon.
Okay, up here. Oh, did you have one too, Michael? Oh, okay.
Mark Webster from City Spring. When you think of this kind of work, how do you guys think about milestones? Like, where do you want to be in 3 months? Where do you want to be in 6 months? Like, how do you keep team members motivated? Like, it seems like a 10-year kind of thing, but how do you break it down into smaller chunks?
Yeah. So the question was about milestones. A lot of people don't know the way DARPA can accelerate their work is that we have milestones and deliverables at every step along the way of a project that we fund. So the program managers in the office that I direct, as well as when I have been a program manager, I'm interacting with the people that are working on these projects almost daily and say, okay, is the milestone that we have set appropriate, or do we need to change the milestone? Or does some discovery vector us off in a different direction? And we can make all of those changes. That's part of the the nimble nature of the agency, and it's part of the secret sauce that enables us to do what we do.
So thank you so much, Justin.
All right, thank
Really
you.
good. Really enjoyed